Hey, so today we'll be going through parameter efficient fine tuning, which is a part of fine tuning large language models. The particular fine tuning technique that we're looking into is called direct preference optimization. So, as you might know, that GPT 3.5 model has been fine tuned using reinforcement learning human feedbacks. Essentially, you might get multiple prompts and you might select one of those prompts as a more suitable answer, and then based on it GPT 3.5 gets more aligned answers. One example could be that a question like what is the capital of China, the answer could be either something like Beijing is the capital of China, or the answer can simply be Beijing. uh, these answers are often based on personal preferences. So, DPO is one fine tuning method that overcomes a need for the reward model, as you can see in the screen, and directly create preference data and use maximum likelihood into something called as Bradley Terry model, which is basically rewarding your preferred responses over your negative responses. This is the paper by Stanford, and the key idea is that you don't need a specific reward model to come up with reward scores that are used in reinforcement learning. You can simply use your own LLM to score and align based on the preference. What we'll try to do is, first we'll try to create a preference data set. Uh, the data set used needs to contain chosen and reject, or probably examples of outputs that show some kind of difference while we are fine tuning our large language model. So for that, what we'll use a Mistral 2.7b model. We'll read the data set called Llama dataset. It is basically instruction following dataset, and for these instructions we'll generate 5 samples of responses. So after running this, we'll get something like this. So this is my first example, and you can see that the question is regarding WP navigation menu, right? And what are the specific parameters, and we can see 5 different samples. By default, if your temperature has a higher setting, then you would generate 5 different prompts, or I mean responses. Then we use a LLM blender to rank these individual responses. We take the rank number 1 or the best rank response as the selected prompt, and the rank number 5 as the rejected prompt. And here we just simply push the preferred data set into Hugging Face. To see how the data set looks like, let's go to Hugging Face. So you can see that we have the chosen and the rejected data sets. Just to recap, we had 5 responses. We selected the best response ranked by LLM ranker, or which is the pair RM model, to create this data set. Now moving on to DPO, the process itself. Again, here we would be using LoRa fine tuning. If you're not familiar with LoRa, I would suggest to check out the video on LoRa and parameter efficient fine tuning first. We select the modules in the base LLM Mistral which we want to tune in, which is the K, V, Q and the dense layers. We set in some configurations like loading the model in a 4-bit configuration. This is basically the DPO configuration required. We can again play around with the different set of things. Here in this step we have the DPO trainer. What specifically beta implies is that a higher beta would make your language model more strongly aligned to your chosen prompts. Setting up a higher beta would be more beneficial if you're if there's a like a very huge difference between the way your chosen and rejected prompts are. Otherwise, a lower beta is generally preferred. And one more problem with a very high beta would be that there might be scenarios that your model just starts predicting slash ends or something like terminated strings or something, because that's how it was able to maximize the maximum likelihood between the chosen and the rejected prompts. This process is very similar to your SFT trainer, the available from the Hugging Face library, which is the LoRa, or probably the LoRa fine tuning method. In the training step, we can see that the loss drastically reduces, and we do 50 iterations. For this, I have used A100 GPU. We save the DPO model, and if you are familiar with the process of parameter efficient LoRa fine tuning or something, or probably when you use QLoRa, this is a process where we merge the adapters back on our model, and we save the model. You can see K, Q, V. These are the layers that we have acted on up along with the dense layer. Now, based on our fine-tuned LoRa, we generate some responses to see if how well are they aligned to our chosen prompts. So you can see this was the first prompt that we had. This is the chosen prompt, and this is the rejected prompt. You can see that the response, at least from what is being displayed, is more aligned to the chosen prompt. In the last step, we pushed the fine-tuned model on Hugging Face Hub, and that's all. Thank you.